Hello guys, so for today's class, we're gonna cover the different types of functions and implied domains, okay? So first, let's do the quick revision. What do we mean by functions? So function is essentially just relations, but we have to restrict our relations into many x to one y, so we call it many to one or one-to-one function, which means one x corresponding only have one y value, okay? So the first one we cover is one-to-one function. So one-to-one function basically means one x gives me one y, okay? That's called one-to-one. And for example, we have like y equal 2x plus 1, or y equals like y equals x cubed. So they all one-to-one functions, okay? So now if we want to test if this function is one-to-one, so we can directly use we call horizontal line test, okay? Horizontal line test basically means you draw the graph, any of them, so you randomly draw the horizontal line over here, over here, over here. So if this line only cut this function only once, okay, only ever intersect this graph only once, so we call this function is one-to-one. Clearly for this problem, we cut 2 points, so it's not one-to-one function, okay? Pretty easy and straightforward. Basically just one x, one y value, okay? So another really important thing over here, I highlight for you guys, is implied domain, okay? So, which means it's another mathematical terminology. It's called implied domain. So if we use a plain language or another word, it's just called the maximum domain. So basically for every functions, we can have infinite many domains. For example, y equals x. We can have the domain x belongs to 1 to 2, or x belongs to negative infinity to 3. It's all the domain of y equals x. But for any functions, the maximum domain or implied domain only can have one, okay? In this case, is x belongs to R. So for our final year exam or for the SAC or even for your practice, normally for every single questions, they ask you about implied domain, okay? They're only gonna ask you about implied domain. So implied domain, in another word, means the domain or the x values can take to make our relation still valid. So it's still defined. For example, we learned square root long time ago, right? Y equals square root x, and this one is also covered in year 11 math method. So we know under the square root, the x value must greater than 0, okay? So this one is our implied domain. And another thing is the domain is the set. So we cannot write the inequality over here. So another way is like domain, DOM, short way, you write 0 to infinity, or you write x belongs to 0 to infinity, or you even can write d 0 to infinity, okay? Either way, just tell the teacher or tell the examiner you're doing the set, okay? You have to remember range and domain, they are sets, okay? Okay, let's move on. So for this tricky part, okay, I want to highlight over here, this guy, and I want to show you how to do this one. So this one, they ask about y equals square root x squared minus 7x plus 12. And they ask the implied domain for this guy, okay? Of course, with our understanding, we know under the square root, our every number or our single numbers must be greater or equal to 0. So it's x squared minus 7x plus 12. It must greater or equal to 0. So let's use the cross product method. we call it x minus 3 and x minus 4 greater or equal to 0. So now it's become the tricky one. So from the book, we can clearly see that they use the graph, the parabola, to directly see and directly can observe it's the greater than 0 is from negative infinity to 3 and 4 to positive infinity. Now I'm going to show you another way to do it, okay? Hopefully it makes sense as well. So again, we know some really key points, which is 3 over here and 4 over here. And we know both, they make our whole equation y is 0. So if we know this point is 0, so it must be left point is less or greater than 0, or the right one is less or greater than 0. So how do we do it? We can plug any number to get and the idea and make sense. So we plug any number less than 3, we can make 0. Just randomly guess, okay, less than 3. 0 is easy, so that's why I choose 0. So I directly plug in our equation. I got negative 3 times negative 4, which is 12. So it gives me positive over here, okay? Which means negative infinity to 3 gives me positive number, which is corresponding to here, okay? And again, between 3 and 4, I can try any number like 3.5 or 3.5 over here. Then I got one positive number over here. Then I got one negative number over here. So positive times negative gives me negative. So I don't want here. And greater than 4, we can plug the number which 5 over here. So it's become positive and positive. So greater than 4 gives me positive as well. And of course, I want greater or equal to 0. So this one I also want over here. And connecting them according to our first unit, the chapter 1a is called union, okay? So it's negative infinity to 3, square brackets, union 4 to positive infinity, okay? That's how we do it. But the essential method is we still need to draw the graph to see this one is greater than 0 and this side is also greater or equal to 0, okay? So let's move on. And another one is called piecewise defined functions. And remember, it had another name called hybrid functions, okay? It's the same thing. Piecewise defined function equals hybrid function. So for example, if your family or you future, you're gonna be 18 years old and you got the driver license, you buy the car, and the salesman tells you, okay, this one is hybrid car. Hybrid means we use gas and we use petrol as well. So it's mixed, okay? So this is called hybrid. According to for our math, the hybrid function means our fx is no longer a single equation. It becomes something connecting together like this, okay? Like connecting together. Or like for example, example 14, the fx is combined with 3 functions. The first one is negative x minus 1 from negative infinity to 0. And the second one is 2x minus 1 from 0 to positive infinity, 0 to 1. And half x plus half from 1 to positive infinity, okay? And we just need to draw them and connecting them. But just make sure if our hybrid function or piecewise function, it looks like this one. So it's x plus 1 when x less or equal to 0, and it's 3 when x greater than 0. So if we want to draw this guy, this one is our number plan. So x plus 1, first when x equals 0, our y equals 1, 0, 1. And when x equals negative 1, and my y is 0. So I connect them. It looks like this one. But when x is greater than 0, I got a constant, which is over here 3, and need empty circle because it's never can equal to 0, and from here. So they got something we called discontinuity, okay, over here. But we're not going to discuss this one in details for now, but later for the chapter 9 math method, they ask us to test if this function is continuous or if this function at this point is differentiable. I will tell you guys in more details, okay? So let's keep going. The next one is odd function and even function. So for even function, the basic idea is fx equals f negative x. So the property is the symmetry about y x-axis. And I can give you the example to remember. Just remember y equals x squared. This one is an even function. So to help you guys to understand what is even function is. And for odd function, it's actually rotational symmetry. Okay, this one is sine or polynomial for the x cube, so it's rotate. Okay, in this way, rotation symmetry. So give you example is y equals x cube. So it's fx equals f negative x equals negative fx. It is odd function. Okay, but not every function can be characterized as odd function or even function. Okay, but for some of functions, and we can use this one, and it helps us a lot, especially in integration, which I will discuss more detail in chapter 11. Okay, so use this one to help us to simplify our calculation. Okay, so that's it enough for today. The basic idea for two math terminologies. The first one is implied domain. I highlight for you guys over here, implied domain. And the next one is piecewise defined function. And for the last but not least, what do we mean by odd? And what do we mean by even? And hopefully this one makes sense. And see you guys on next video. Thanks. Bye-bye.